Hello everybody, welcome to Golden Career classes. Today we will conduct the class for topic which is mensuration. Mensuration is a topic which considers the part of the maths which is about volume, surface areas, perimeters. All these type of topics are covered under mensuration. If you have any query or suggestion, please mail us at info@goldencareer.co.in. For those who have not registered with us yet, can register for SBI PO batch and SSC CGL batch. The links are available on our website, which is www.goldencareer.co.in. Registration fees for SBI PO is 10 rupees and that for SSC CGL is 25 rupees. So we will start our class now. We will first discuss the formulas which we would need to solve the mensuration part of the questions regarding mensuration. Then we will proceed through questions and all. You all will be getting the assignment within a few days. That will help you practice more and more. So first is rectangle. Rectangle is a quadrilateral basically. The speciality of this plane figure is that its opposite sides are equal and parallel, and all the angles are here 90 degree. If AB here equals to L, which is length, and BC is B, breadth, then area of the rectangle will be L into B. Perimeter is basically the boundary of any plane figure. If we start from position A and move through the line here and again come back to A, then the distance which we cover is actually the perimeter. So perimeter of this rectangle will be AB plus BC plus CD plus DA. As we have already mentioned that opposite sides are equal, so we can write if AB is equal to L, BC is equal to B, then CD will again be L, and this will be D, and this will be DA, and DA will again be B. So here we'll get the perimeter like 2L plus 2B, which is equal to 2 into L plus B. Now we will see about square. Square can be considered as special type of rectangle. Here all the angles are 90 degree as in rectangle, but the speciality is that all the sides are equal here. So if we consider that each side is A, then area will be A into A, and perimeter will be A plus A plus A plus A 4 times, which is 4A. So square is done. Then we have parallelogram. Parallelogram is a quadrilateral. The relation with rectangle and square is that both square and rectangle are parallelograms, are special cases of parallelograms. in which all the angles are 90 degree, and for square all the sides are equal. This is the specifications which we get for square and rectangle being a parallelogram. But if we consider parallelogram in general, then we have only 3 criteria for any plane figure for being a parallelogram. Opposite sides are equal, means AB is equal to CD and AD is equal to BC. Opposite sides are parallel. As the name suggests, parallelogram, opposite sides are parallel. And the third criteria is that opposite angles are also equal, means angle A here will be equal to angle C and angle B here will be equal to angle D. So this is a parallelogram. If we drop a perpendicular from A on CD, then this AE will be height of the parallelogram, which is basically the distance between the two parallel sides. If we have this, then the area of the parallelogram will be equal to height, which is AE, into the base on which the height is perpendicular. Here it is CD. So area here will be H into base. Here base is L. Please keep in mind the perpendicular, on the side which we drop the perpendicular is the side which should be mentioned here. If we drop the perpendicular from B like this, and if we extrapolate this region, here we have in this case area will be equal to BF into AD. Here we will measure only up to AD, not AF, where the perpendicular is dropping. But the base is, since AD is extrapolated, base here will be AD. So area will be equal to BF into AD. But this area here will be equal to area here. Therefore, we will have BF into AD equals to AE into CD. Now here comes the perimeter. Perimeter, as I have already mentioned, is the boundary, is the distance here from when we cover from this region, then this, then AD. So perimeter of this parallelogram will be AB plus BC plus CD plus DA, which is again like triangle, rectangle, 2L plus B. Then we have triangle. For triangle, here we have two formulas to calculate the area of the triangle, and we will see what are these formula about. Here like we have triangle A, B, C, and if this is the perpendicular here, AD, then area will be equal to half into base, which is BC, into height, which is AD. Here we will also keep in mind the base on which the perpendicular is dropped is the base which should be used here. So we have a set of base and height. This AD will be height, or we can also have like this BF, then area will be equal to half into AC into BF, or we can have the same area is equal to half into AB into CE. So when we use the base, we use corresponding height, and in all the areas will be same because we are calculating the area of the same triangle. This is the area calculated when we have given one of the sides and corresponding height. Corresponding height means when BC is given, we must have AD. If AC is given, we must have BF, and if AB is given, we must have EC. Then we can calculate the area of the triangle. But if we have given we are given all the sides of the triangle, like this side is given, length of the side is A, length of this side is B, and length of AB is C, small c. Then how can we calculate the area of the triangle? So here we use Heron's formula, which is area of the triangle is equal to root over S into S minus A into S minus B into S minus C. Here A, B, C are the length of the sides of the triangle. Then what is S? S is here semi-perimeter. As the name suggests, semi-perimeter means half of the perimeter. Perimeter of the triangle will be A plus B plus C. Then half perimeter will be A plus B plus C divided by 2. This is the value of S. And this, if we are given all the sides of the triangle, then we can easily calculate the area of the triangle. This is the Heron's formula. Next we have right triangle. For right triangle it is very easy, because when we consider for different triangles, we must be given either all the sides or the height and the base. For right triangle, one angle is 90 degree. So one of the sides is already can be considered to be height. Like if we have this triangle ABC, either BC or AC, any one of the can be considered the sides which make 90 degree. Keep in mind the sides which make the angle 90 degree. Either of the sides can be taken as base and perpendicular. Base or perpendicular. We can take AB as base and BC as height, or BC as base and AB as height. So here the area will be half into the sides which make the 90 degree angle. So right angle is very easy. Now we will proceed further. For equilateral triangle, since the figure is very symmetrical, we calculating areas for equilateral triangle is somewhat easier than other triangles. Sorry. For equilateral triangle, A equals to B equals to C. So we will have AB equals to BC equals to AC. If we drop a perpendicular from A to BC, then it will intersect BC at midpoint. So if we consider this point to be D, then BD will be equal to DC for an equilateral triangle. So using Pythagoras theorem, AD square plus DC square must be equal to AC square. Since here we have a right triangle, so we need to calculate AD square, which will be equal to AC square minus DC square. So AD will be root over what is AC square. AC is equal to A minus, then what will be DC? DC will be A by 2, since the perpendicular divides BC into two equal parts, and we have A square by 4. When we do A by 2 square, it is equal to A by 4, A square by 4. So here we have root 3 by 2A. This is equal to height. And area of the triangle will be half into base into height. What is base for an equilateral triangle? It is same, since all the sides are same. Here the base will be A into, and what this is the height that we calculated here, into root 3 by 2A. Then area of the triangle equals to root 3 by 4 A square. I hope it's clear to you. And if we talk about perimeter, as we know, perimeter is the sum of all the sides, then A plus A plus A equals to 3. This will be the perimeter of the equilateral triangle. Here small a is the side length of the triangle. Next we have the trapezium. This type of plane figure is known as trapezium. Here only one condition follows. AB is parallel to CD. That is, only one side of the quadrilateral, one pair of opposite sides are parallel. Other two sides which are opposite to each other are not parallel to each other, neither equal to each other. So we should keep in mind that AD is neither equal to BC nor parallel. So if we have a trapezium like this, then the area of the trapezium will be, if we consider AB to be small a and DC to be small b, area is equal to half into height. Here h is height, it is the distance between the two parallel sides, okay, h into sum of parallel sides. Therefore area becomes half into height into A plus B. This is the area of the trapezium. And perimeter will be sum of all the sides. Since here we don't have any relation between the opposite sides or adjacent sides, so here we can't generalize any perimeter formula. It is rhombus is a figure which has too much similarity with the square, but it has some distinct differences between square, but there are still some differences between the rhombus and square which can be easily understood. Like if we have a rhombus like this, we have a rhombus, the only similarity between a rhombus and the square is that all the sides are equal here. For a rhombus, AB is equal to BC equals to CD, and which is equal to DA. This holds for a rhombus. But for a square, all the angles are 90 degree, but here the angles are not 90 degree. Here the opposite angles are equal. Rhombus is also a parallelogram which has all the sides equal. So if we have any rhombus given and we have if we know the diagonals of the rhombus, like for this rhombus we consider AC and BD, then area of the rhombus will be equal to half into AC into BD, where AC and BD are the diagonals of the rhombus. If AC is D1, then BD is D2. This is the area of the rhombus. Here D1 and D2 are the diagonals of the rhombus. And if we consider perimeter is same as the square. That is A plus A plus A plus A is equal to 4A. Now we have circle. If O is the center of the circle and this is the distance of the circle from its boundary, then this distance is called radius. And if this chord, if this extrapolate this radius to the other half of the circle, then this AB, if we have AB, a straight line which passes through the center and joins two opposite parts of the circle, then then AB is called diameter. As we know, R is equal to AB by 2. If we consider AB to be the diameter, if we consider it to be D, then R will be D by 2. Now taking into account area, then area of the circle is pi r square, where r is the radius of the circle. The only defining parameter of a circle is its radius, and there are no other parameters like length, breadth, like in other plane figures, height. We only have here is radius. Pi is a constant which has a value of 22 by 7 in fraction, which is also equal to 3.14. We mostly use this fractional value because while we calculate, it is easier for us because it somewhat cuts with the diameter when we multiply something and makes our calculation easier. So we are done with the area. Okay, as we have seen that area is equal to pi r square, if we put r is equal to d by 2 here, then we have pi d by 2 square, which is equal to pi d square by 4, which is this formula. Now comes the circumference. Circumference is the perimeter. Perimeter of the circle is known as circumference. It has a formula which is 2 pi r, or circumference of the circle is 2 pi r. If we take this 2r, it becomes d, then the circumference becomes pi d. Next is the area of the sector. Area of the sector is the area covered by this arc and the two radius. This region is called sector. If we need to find the area of the sector, if we have this circle and we have this sector and it is angle theta, if this arc AB subtends an angle theta at the center, then how can we calculate the area of the sector? It is very easy. The area of the whole circle is equal to pi r square. We know, we multiply the area of the whole circle with theta by 360 degree. 360 degree is the total angle if we start from B and move about the circumference of the circle and come again B. The angle which we cover is 360 degree. Here one thing to note is that when we have when we multiply the area with theta by 360, theta must be in degrees. There are two units to measure angles. There are two units to measure angles, which are degree, or second is radians. For radians, pi is equal to 2 pi is equal to 360 degree and pi equals to 180 degree. So if we have theta given in degrees, then we divide by 360 degree and multiply it to whole area. If not, then we have pi r square. If the theta is given in radians, then we divide theta by 2 pi. Then this will give us area of the sector. Next we have the frustum. This type of figure is known as frustum. This is actually made from a cone. If we have a cone like this and we chop off this head part of the cone, the remaining what we have is called a frustum. It is made from a circular cone. Circular cone means a cone which has a base of a circle. So the curved surface area, for when we have a 3D figure which has length, breadth and also some height and occupies some volume, those figures are known as 3D figures. For 3D figures we have curved surface area, concept of curved surface area and total surface area. Curved surface area is the part which does not consider the top part and the bottom part. It only considers the curved part of the figure. So for a frustum, the curved surface area, which is also known as lateral surface area, is equal to pi into h. H is the, here we can see in this figure, h is the distance between the top and the bottom. This is the height. The center of the two discs of the top and the bottom, when we join this, the distance between these discs is height of the frustum. So the formula for this, we have a curved surface area is actually equal to pi h into r1, which is the radius of the top of the frustum, plus r2, which is the radius of the bottom, which is the base of the frustum, this is the curved or the lateral surface area of the frustum. Then we again have another type of surface area, which is total surface area. In total surface area, we also add the areas which is covered by the top and the bottom. So for total surface area, we add the areas of these circular top and bottom to the lateral surface area. Then it will become pi h r1 plus r2, which is the curved surface area, plus pi r1 square plus pi r2 square. So here we have pi in common. So pi h into r1 plus r2 plus r1 square plus r2 square. This will be the formula for the total surface area of the frustum. Next we have a cube. In cube all the edges are of equal size. All the sides, if we consider A, then all the sides are A. This height, this breadth, all are A. So the volume of the cube will become length into breadth into height, as we know the volume, therefore volume will be A into A into A, which is equal to A cube. Then again we have lateral surface area, which is also known as curved surface area, and then again only surface area, which here is total surface area. For a cube, just move your eyes around your room and imagine that for curved surface area, the area of the walls, if you add only the area of the walls, then you will have area of the four walls, then you will have only the curved surface area. If you just eradicate the top roof of your room and the floor of your room, area of the floor and the roof are not taken into count, so only the sum of the areas of the walls is considered, then it will give us curved surface area. And when you add to this curved surface area the area of the roof and the floor, then we get the total surface area. You can consider your room to be a cube, so it will help you to understand these this curved surface area and total surface area concept. Since the sides of cube are same, then area of each face will be A square. So if you have your room and the length, breadth, height, everything is A, then if you add the area of each face, each wall will be A square. When you add all the areas of the four wall, then you get what you get is 4A square. And to this 4A square, when you add the area of your roof and the floor, then you get 6A square. So since cube has all the edges equal, it is easier to understand the curved surface area and the total surface area of the cube. The problem arises for cuboid, since cuboid does not have all the sides equal. If we have this cuboid, if we consider AB to be height, BC to be breadth, and BD to be length, then the volume will be length into breadth into height. And here for total surface area, if we add all the areas of all the sides, like this side, this top side, this back side of this cube, and this front face of this cuboid, if we add all of these, then what we get is total surface area, which is 2 into length into breadth plus breadth into height plus height into length. Here, to understand the total surface area, you can again consider your room, considering height, length and breadth of your room and calculating areas of each of the face, which is floor and all the four walls and the roof, then you get the total surface area to be this. Then we have a right circular cylinder. For a right circular cylinder, we can have two kinds of cylinders, like this cylinder. It should be symmetrical, the distance should be same throughout. If we have a cylinder like this, perpendicular is like this, okay, and second we have cylinder like this. these type of cylinder are called right circular cylinder. So we'll study only right circular cylinder. For a right circular cylinder, volume is equal to pi r square into h. If we consider the radius of the base or the top, both base and the top, to be r, since it should be, both the circle should be of same radius, then the area of this plate, this disc, will be pi r square. Base, area of the base will be pi r square. If the height of the cylinder is h, that is distance between the two, top and the bottom, is h, then pi r square into h, area of the base into height, will be the volume of the cylinder. Then we have pi square h. Here we also have lateral surface area and total surface area. If we see the curved surface area, it is equal to 2 pi r into h. As we know, the circumference of the circle, which is the base here, if the radius is r, the circumference of the circle will be 2 pi r. This circumference into the height, circumference into height will give us the curved surface area, which is 2 pi r h. Here we get the lateral surface area. To this 2 pi r h, if we add the areas of this top sheet and this bottom sheet, bottom disc, both, it is so for total surface area we have TSA equal to 2 pi r h, which is the area of which is the curved surface area, plus area of this sheet equal to pi r square, plus area of this disc pi r square. So we add 2 pi r square. So we are having 2 pi r in common. We have this. Total surface area becomes this. So we are done with right circular cylinder. Then we have right circular cone. If we have a cone, then OA is equal to height, OB is equal to radius of the base, and AB equals to slant height. Okay, here AB equals to slant height. Using Pythagoras theorem, AB equals to under root h square plus r square. So for curved surface area, which is the area of the circular cone except this base, this is equal to pi RL, pi into r into L. Here L is equal to h square plus r square root, which will be equal to pi r into root over h square plus r square. This is the curved surface area of the cone. To this curved surface area, when we add the area of the base here, what we get is the total surface area. Total surface area is equal to pi r L plus pi r square. This is the total surface area having pi r in common, pi r into r plus L. This is the total surface area. So now for volume, if you remember the volume of the cylinder, so if we have a cylinder which has height r and radius which has height h and radius r, then what is the volume? Volume is equal to pi r square h. So if we have a cone of same height and same radius, then the volume is 1/3 of the volume of the cylinder. So if we remember the volume of a cylinder, formula for the volume of cylinder, we will find that volume of the cone will be 1/3 of that cylinder. So volume for cone is 1/3 pi r square h. This is the volume of right circular cone. Next we have hemisphere, not hemisphere, sphere. So sphere is a 3D circle, what we can say, a ball. So for sphere, volume is equal to 4/3 pi r cube. This is the volume for a sphere. Please try to remember all the formulas. If you do few questions for using all the formulas, it will be very easier to remember all these formula. It seems that it is very large number of formulas, but it is not. It will be very easy to remember if you just solve few questions. Then you will memorize all of the formulas. For a sphere, we don't have curved surface area or total surface area. We only have surface area, which is equal to 4 pi r square. If you remember, area of a circle is equals to pi r square. So for a sphere, area is 4 times the area of a circle of same radius. So for a sphere, the surface area is 4 pi r square. So area of the surface area of a sphere is 4 times area of a circle of same radius. Now considering hemisphere, as the name suggests, it is the half of the sphere. If we cut the sphere from the center, my cut is not at the center. So if we cut this sphere from the center, if this is the center, and divide it into two parts, then we have two hemisphere. Of radius r. So for such a hemisphere, if the volume of the sphere is 4/3 pi r cube, then the volume of the hemisphere will be just half of it. So volume of the hemisphere is 2/3 pi r cube, which is half into 4/3 pi r cube. So here we have 2. Since hemisphere has two types of surface, one this curved part, and other this circular flat portion. So for hemisphere, we have curved surface area and total surface area. The curved surface area of the hemisphere will be half of the surface area of the sphere. Why? Because for sphere we only had the surface area. When we cut the sphere into two parts, then we have two types of area. One, the area of the circle, which is the flat part, and remaining the curved surface. Curved surface will be just half of the surface area of the sphere. So curved surface is 2 pi r square. And to this 2 pi r square, if we add this area of this circular face of the hemisphere, then we have 2 pi r square plus pi r square, which is the area of the circle. We get 3 pi r square. So with hemisphere we conclude our formula part, and I'll give you just one question. You try to solve it and comment your answer below, and just see if your answer is correct or not. It will be even helpful to you. We have a rectangular park of length 24 meter and breadth 14 meter. We have to make a 1 meter wide pavement along this park, around this park, like this. To make this pavement, we will use a marble. We will use 20 centimeter by 20 centimeter marble. So you have to tell me the number of marbles which we need required to make the pavement. Comment below your answers, and let's see who gets our answer correct. So if you like our video, please subscribe our channel. Just share this video more and more to your friends and help them. And if you have any suggestions regarding the video or any improvement that you want from our side, please feel free to comment. So thank you.